All right, with that, depot autonomy. So this is in the infrastructure assisted, infrastructure enabled autonomy, where smart infrastructure investment is happening. How can we use it to do better autonomy? And the use case I'm looking at is within a depot. Think like an Amazon fulfillment center. So within that constrained operational design domain, a depot with a fence line around it, everybody inside, it's an employee, everybody knows and is trained. But within that constrained operational design domain, how could we take vehicles that have just normal cameras and radars like happen for level 2 driver assistance features and make them autonomous L4 AV capable by adding infrastructure perception and routing? So how do you take the existing sensors that are on existing vehicles and the sensors that are in the infrastructure and use some smart algorithms to get them to work together so that they can actually autonomously marshal vehicles through the space? And this, we've shown this video a number of times, but, here's MCity. Our pitch that we're going to make to NSF for funding is to expand the footprint of MCity into building an actual depot space here, connected to MCity on this side and connected out to Green Road on that side. And I'm going to skip the video in the interest of time here. But what we've been doing really intensively, I've spent a lot of time on this, is assembling the coalition of the willing here. And I really am focused on not only doing technical feasibility, which is what we're all used to, the engineering task, but also looking at the business opportunity, because great engineering ideas never see the light of day unless there's a solid business case. So, figuring out the business opportunity is critical, as well as documenting engineering requirements. Because, when I was at Ford and people in academia did research and just sort of made a white paper or something, that was not really what I needed. What I needed was the specifications. How do you build something like this? What requirements does it need to meet? How are you ensuring safety? How are you testing it? What are the performance metrics you're testing it to, right? Documentation of the systems engineering is critical for that. So the folks we've got working on this, since January, we have Katie Skinner and Ram Vasudevan from robotics, with a team of students working on the perception and planning stack. We have just signed on Nobilis to do the orchestration part of it. So think of that as like the air traffic control system of the depot. And Nobilis has created a really interesting state-of-the-art way to do that that's decentralized, which is really interesting, which is why we've signed them up to do that work. Aline Eid is doing precision localization. It's part of our safety case. So trying to figure out where all the humans are in the environment and robustly tracking them, because the number one failure mode we need to avoid is having our autonomous vehicles hitting workers in the fulfillment center. Communication networks is critical as well, right? If you've got vehicles driving around and infrastructure sensing and routing, there needs to be robust communication between the two. And Professor Shinsha from University of Dearborn is going to work with us on that. He recently came from UCLA, where he worked on the Open CDA standard. And so he's going to be helping us with the communication networks part of depot autonomy. And there's a startup called NIFT, which is creating our test platform. They're actually creating it for the students in Tech Lab. It'll be a Tech Lab project in winter term. But this would be like the electric skateboard chassis kind of the thing that would be autonomously marshaled through the depot. But it'll be a completely open source platform. So the students will be able to completely control, reprogram it any way needed. On the business side, Peter Adrians has done a lot of work on infrastructure finance. And so he and a MBA student who he's advising are helping us with the business case, as well as we have a Ross team of 4 MBAs that are working on the business case as well, and the market sizing, like what's the market potential for depot autonomy. On engineering requirements, we have Gaurav Pandey from Texas A&M, who's doing the concept level work. And then we have student teams under Professor Boardley, who are doing the systems engineering work as capstone projects in their coursework. And then CAMP, the consortium that's run by GM and Ford, is working with us on developing an SAE standard to sort of codify how to make the system interoperable for vehicles and infrastructure that would then be published in an SAE standard. So that's our team that we got working on it. Schools that we're touching within U of M right now, the ones at the top here in bold are ones that we're actively engaged with right now. With my focus, being to try and make these as multidisciplinary as possible. And these are the ones we're reaching out to right now. School of Information, both on some of the data science topics, as well as some of the human machine interface topics. Aerospace engineering, because we'd like the depot to be multimodal, to have, drones coming in and out, as well as delivery vans. Architecture school, because we'd like to make the depot a software-defined building, right? We don't want to just make it a dumb brick and mortar, right? We want to make this a modular, updatable, fully connected building of the future that can be updated by software. Law school and public policy, I've added more recently, actually, because, it's just, there's an article in the Wall Street Journal I saw just this morning that the headline of it is something like, that the dock workers are protesting automation in shipping yards, and so there's a real, larger societal context for how does automating these things, affect the people who were doing those jobs, right? The companies say, well, we can handle more freight, so we'll get more business, so we'll need more workers. But what the workers see is that it used to take 30 people to do a job that's now being done by 4, right? And so sort of balancing that and having that larger discussion, which is great for us at M-City because we're not really going to make depot autonomy. We're not capitalists in that sense, right? We are researchers looking at this as, and so we can take on the hard questions, right? So that's one of our advantages. Industry partners. So we're always looking for industry partnership, right? Obviously, depot operators would be sort of my number one group that I'm looking to recruit. Smart buildings, I think this is a really interesting space. Network providers, obviously the communication networks are critical. The vehicle platforms, so, OEMs that would have vehicles that would need to interface within a depot environment, as well as tier 1 suppliers who are actually developing some of these systems already. So opportunities to get involved for those that are interested. Our goal is, as Henry said, is to get a large NSF funded project, $20 million to do this work. Okay, made it. Questions?
Presentation, Greg. There's so many issues we'd like to talk to you about in your presentation, but some of the parallels to the things we're doing. But just a couple comments on the depot work. Have you considered reaching out to the DoD, Logistics Management Material Command, because they have a strong need for, for supply management? Their depots are very chaotic typically, the toilet paper doesn't end up on the same place, when they're mobilizing troops. So some sort of smart autonomous material management in depots that they have to set up on the fly. It's an excellent application for the.
Yeah. I would love to utilize your network to do that. Noblesse has indicated that they have some of those connections, but you know how the connections go, right? It's always good to have multiple networks to work through. So yeah, I'd love to talk to you about that. DoD is obviously very attractive to work with, so we would love that.
And just another follow-up is we've been tracking the longshoremen strike on the West Coast and the East Coast too, doing a lot of analysis of the economic impacts of that too. We have an economic modeling framework called MUST that could be